Hey folks, Quill18 here, and welcome to another, I was going to say, episode of Let's Play Unity. We're working on Project MightySpud over here, our Unity project, where we're doing a terrain generation system for a planet, basically. And we've done some great work so far here, really happy. We've dealt with a lot of really hard things. There's still a possibility that there might be a little bit of tweaks here and there that have to be done, but overall I'm feeling very good. Basically, we can pick an arbitrary place on our planetary sphere to choose as a landing place, which is what the center chunk of this terrain is, and then we are generating extra chunks next to those. We're using the Unity terrain engine to handle this, which does a level of detail, which is why, see, this area seems like it's got the seam here that's fuzzy. It's because it's just rendering at a slightly different level of detail here. There's still the issue where there are going to be these tiny little gaps here at this time. And there are two reasons for that. One is we do have to tell the terrain what its neighbors are, because these will never have exactly the same values because of just slight floating point differences here and there, and the way the terrain gets generated, especially with level of detail. So we have to tell the terrain what its neighbors are so it can properly stitch that up. But also, I think because of the large size chunks we're using, there's still going to be a little distortion on the side that might lead to slight micro differences that we have seen. So we'll be looking at correcting that next. In addition to that, very, very soon, what we're going to do is start working on the system where our character is going to start working, say our character is here, and he's going to move towards the right, which happens to be east in this case, but that's not always going to be true. Positive X is not always going to point to the east. But at some point, our character is going to go here and cross the boundary into this chunk, at which point what we'll want to do is kind of destroy this chunk and spawn a new one over here. In practice, though, as we'll discuss as we go forward, I don't think we're actually going to want to destroy the object and then respawn it. I think what we're going to want to do is simply take an existing chunk, move it over here, and rebuild the terrain. You actually want to try to do that as often as possible in Unity, because as you destroy a bunch of objects, the garbage collection system has to go and clear out that memory, and that can cause the occasional little micro stutter in your program code that is short. But even if it's like, even if it's just a tenth of a second, that's very, 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 very noticeable. As these extra little stutter in the game makes it a little bit unsmooth, and actually can be considerably longer than that, especially when you're talking about something that takes up a fair amount of memory, like the terrain chunk over here. So instead of destroying it and recreating it, what we do is move it here and then give it new, we just change the heights around here, right? We grab the heights array, we change the height values, we feed the heights array back in there. If there's a possibility that internally there's still going to be some memory allocation or deallocation, that's entirely possible, but it's going to be very, very, very minimized. Also, I want to address, got a couple of comments asking, why aren't we just generating our own, say, like, spherical terrain generator or something like that from scratch. I did talk about this in the first video. That there's pros and cons to like writing, a completely from scratch system versus using something from the asset store versus this sort of middle ground where using the built-in terrain Unity terrain engine. You have to remember what the Unity terrain engine is doing for us is a couple of really powerful things. First of all, it is highly optimized, which is one of the reasons, as I pointed out before, for example, you can't actually rotate these chunks. Here, I'm currently rotating these chunks. It becomes really obvious if I use this, right? I'm rotating this object, but that doesn't change anything. That's because of certain internal optimizations that are being done that allows Unity to render this terrain very quickly. It automatically does level of detail for us, which is actually a relatively complicated thing to work out. It does splats for the terrain textures, which is actually something that would be very tricky for us to do, and a few things here and there. So by using the built-in terrain system, we're winning a lot in terms of efficiency and a certain set of features. And it would actually, we'd probably spend way more time trying to do some sort of spherical rendering system and not end up with something that works as well. Because it would be really weird, because for every object in the game, like, we'd have to either write our own physics system, or before every physics tick for every object, we'd have to give it a new down. Like in the physics system here, I can specify the direction of the gravity. So for each object, the gravity would obviously be pointing towards the middle of the sphere. So for each object, it would need its own custom gravity vector, which means probably we wouldn't actually be able to use the real physics system. At least we wouldn't be able to use the real physics gravity. We'd have to like turn off gravity effectively, and for each object in the game, manually add the gravity effect to it. So there's all these things you would have to do on top of your normal code to do a true spherical system, which would likely add a ridiculous amount of overhead, tons of opportunity for mistake as well, just be less optimal, less feature rich, as well as more prone to bugs. So that's that. All right, enough of that. This episode, we're going to start off with working on stitching the terrain together. But in doing so, we're going to be setting up the groundwork for that sort of terrain respawning system over here. And here's why. So over here in our dynamic terrain chunk code over here, which, by the way, I need to go and just update that comment there. That's bugging me a little bit. In this dynamic terrain chunk, for example, right, this is where we create the actual... well, we define the actual terrain over here, right? We set terrain data, terrain collider, all that kind of stuff. One of the things you can do with the terrain object is you can call something like terrain.setNeighbors, okay? And you can tell the terrain who its left, top, right, and bottom neighbor is. And this will cause it to seamlessly stitch together things at the seam. Again, we still have to do a little bit of tweaks to make sure that there's not any sort of weird distortion there, but this will eliminate the gap in the first place. And even if we fix all the distortion problems, for example, there's still going to be the issue of some seams if we don't set neighbors here. So that's fine. Okay, so we set neighbors. That's great. That's built into the terrain engine. That's fantastic. The problem is this. It needs to know who this left, top, right, bottom neighbor is, right? Which makes you think, okay, well, we could probably pass this over here. We could do something like, you know, some sort of array of neighbors that we pass to this build terrain. And I mean, we really do want to get rid of build terrain from the start function here. In fact, dynamic terrain chunk, no start function whatsoever. Instead, what's actually going to happen is in our dynamic terrain master, when we build the chunk, we're going to want to do something like, aha, I'm going to tell, oops, this is probably not public. There we go. Public build terrain. I'm going to tell the dynamic terrain chunk that now it should build itself, and I'm going to tell it something about its neighbors, okay? I'm going to pass it some sort of array that describes its neighbors. The problem is this, even the dynamic terrain master can't pass the list of these neighbors to this terrain over here. Why is that? Well, we are building these chunks one at a time, right? We're looping through, and right now we're doing a 3x3 area, so 9 total chunks. Well, we start in, say, the top left corner. Top left corner is the first chunk that we make. And obviously, that top right corner, or top left corner chunk has 2 neighbors. It has a neighbor to the right, and it has a neighbor to the, well, we're going to say south, right? Even though that's not literally south. But in a sense, it's got a neighbor to the east and a neighbor to the south, that top left chunk. But they haven't been built yet. They don't exist yet, which means this top left chunk, when we build it, we actually can't pass it its neighbor. It's not possible. It's like, oh, well, that's a bit of an issue, isn't it? Well, what it means is we have to start setting up the idea of rebuilding a chunk. We have to separate the job of creating our terrain chunk objects from defining our terrain chunk objects. Right? So the first pass has to be, okay, we're going to create all these game objects. We're going to add a dynamic terrain chunk to them. And each one of these actually should, at this time, create its terrain object and terrain collider. Could actually get past the terrain data at that point. That's fine. But then we need a second pass to stitch the neighbors together. Okay, so let's minimize how much change we're doing up front. Let's leave things as is. So we are not passing the neighbors here because that would cause an error. I think if I just go to Unity, we're good right now, right? No errors, everything's good? Yeah, okay. So we've got this build from landing spot, which these things might change, but we're going to say something like rebuild chunks. Okay? So the job of this function at first, will tell each chunk who its neighbors are. Okay, That's its only job right now. We're going to be doing more with this. This is going to be involved in moving the chunks later as the player moves around the world. But right now, that's going to be that. So how do we need to do that? Well, we need to loop through all of our existing chunks. Okay? But we don't actually have a reference to that right now, which is interesting. So clearly, we need some sort of array where we keep our track of all of our dynamic terrain chunks. That seems fine. So we're going to call this, I'm just going to call this terrain chunks to minimize our spelling, or our typing a little bit. This is going to be an array. All right. And in our build from landing spot, I guess we could even make it a two-dimensional array. Sure, we'll make it a two-dimensional array. So in build from landing spot, what we're going to make sure to do is instantiate it. So that's going to be equal to a new array, which is going to be size based on num calls, num rows, like that. Okay, so now we have this array. And after we build a chunk, I'm going to get build chunk here to actually return to us the dynamic terrain chunk that was built. So we'll return the DTC. So then, when we've got build chunk over here, I can say, terrain chunk x, y is equal to this. All right, that's good. Excellent. We can totally do that. So now to loop, we can do something, well, it'll be exactly the same loop as over here. We're going to do an XY loop for our rows and columns. Like that. And so for each one of these terrain chunks at X and Y, we're going to tell it to set its neighbors. Now, I'm trying to decide. I don't think I want to make our terrain component public in any way whatsoever in our actual terrain chunk. So I think what we're going to do is we're going to have a function called setNeighbors. Actually, how does he spell it in Unity? Is it the American way? I think it's the American way. Terrain t equals get component terrain t dot set. Yeah, they spell it without the u. Okay, so I'll do the same thing for consistency. That's fine. So it wants left, top, right, bottom passed over here. So we'll do the same thing. We'll do terrain left, terrain top, terrain right, and terrain bottom. So a bit of a wrapper for that function, because we could get the component. There's no public, private, or anything for this. I could easily get the component from the script over here. But maybe we're going to want to do something else when a neighbor gets set. Who knows? So let's go ahead and just wrap this. That's going to be okay. So we're just going to pass in the actual terrain set neighbors. We're going to say left, top, right, bottom. Now, most of our terrain won't have all four neighbors in here, right? Because if in the example of our top left terrain chunk, it has no neighbor to the west or north. Again, it's not guaranteed to actually be in the western direction and northern direction, but for the sake of argument, let's say that. So that chunk won't have that. So left and top will both be null. That's okay. You can pass null terrain over here. Totally fine. You can also unset neighbors when things break by, you just call this again and do that. Actually, one of the interesting things is that this, I don't know if after you set neighbor, if you have to call flush. It's possible, right? So there's a good example for the wrapper over there. You're supposed to, after you make any terrain change, call flush. So we'll go ahead and do that after set neighbors. All right, so for our terrain chunks, these are terrain chunk, dynamic terrain chunk objects. We can call set neighbor, or we could, if we remember to make this public. There we go. So now I can do set neighbors. And so it needs the left, top, right, and bottom. So what we can do here, I'm tempted to do a bunch of stuff in trinary operators, even though it tends to lead to like ugliness and gore. So let's go for clarity over here, right? So we're going to do the left terrain. Now, the left terrain, you can only have a left terrain if what? If your x is larger than 0. If your x is equal to 0, that means you're on the left edge, and therefore you don't have a left terrain. So if x is equal to 0, we're going to use we will use the trinary operators, but we're going to break it up instead of having it in a giant parentheses over here. And making this variable does not cause any overhead because we're not allocating any more space, really. So if x is greater than 0, that means we're allowed to have a left neighbor. So our left neighbor is actually going to be the terrain chunk at the x minus 1. So the x minus 1 is the terrain chunk to our left, and on the same row, the same y as us. Otherwise, it's null. There's no neighbor. So there we go. That's fine. So we're going to do the same thing for, for top and right and bottom. And we're just going to align this as much as possible. So the top, you can only have a neighbor above you if your y is greater than 0. Because if you're at y0, that means you're on the top row, so you have no neighbor to the north. So what we'll do is this, minus 1 over here. Again, we'll line things up. Excellent. So what about right? Well, you can only have a neighbor to the right if you're not on the rightmost row. So you're allowed to have a neighbor to the right if your x is less than numcalls. Is that right? Think about it. It's actually not, because numcalls in our example will be 3, right? We have 3 columns, but x goes 0, 1, 2. So even if in the most rightmost case, x is 2, which is less than numcalls, so we try to get a neighbor to our right, which would be no good. So we actually have to say numcalls minus 1, or x plus 1 is whatever, but this will still get us pretty close here. Let's go ahead and keep aligning this over here, like that. So if we are not the rightmost thing, that's okay, because now we can say x plus 1. I guess with this kind of thing, we could... No, it's fine. I think this is a perfectly clear way of going it. And then finally, for the bottom, it's the same sort of logic, except to the y. If y is less than num rows minus 1, then we say that terrain chunk y plus 1 is your rightmost, otherwise it's null. And then we just pass left, top, right, bottom over here. There we go. So we've got rebuild chunks. So we're going to call rebuild, after we build from landing spot, and we build all these, we're just going to go ahead and call rebuild chunks right away. So now our terrain chunks should be all told who their neighbors are. Let's see if we've got any syntax errors. We do. Oh, yes! Terrain chunks are dynamic terrain. Like this is dynamic terrain chunks. It's not actually a terrain. Let's actually do that. Let's pass the dynamic terrain chunks to this function. And for this function, we're going to do this. And what we are going to do is we're going to cache our terrain object, which we're not doing right now. So terrain, and terrain data, may as well do that too. Terrain data. Let's do that. So here, we're not going to create a temporary. We'll just have it here. That's going to be fine. These are private, or rather protected by default. So that's okay. So here we can say left.terrain. There we go. Top.terrain. Copy. Right, and bottom.terrain over there. Okay, now we should have no more syntax errors. Do we have any logic errors? Hit play, see if we get any weird errors that way. Null reference expansion. Object reference not set. Oh, yes. Because here we actually can pass nulls. Yeah, that's fine. So, I mean, either we pass the terrain itself as opposed to the terrain chunk, or here we do some extra work. I guess I'll do another round here. I know it's a little silly, but I think ultimately it's going to lead to the best. So here we're going to call left terrain is equal to, if left is equal to null, then we return null. Yeah. Otherwise, it's left dot terrain. Now I realize this is starting to feel a little bit awkward, but I think is fine. So top, right, and bottom. Top, right, and bottom terrain. And that's actually what we're going to use here. Maybe the indirection ends up being too much of a pain here, but I suspect we'll be doing some more work here later on, and we're going to want to be able to access the terrain chunks directly, and we're going to want to be able to do the extra safety layer of checking these objects directly. Let's try to do this again. There's no terrain attached to... to new game object. First of all, I hate that they're all called. What order are we doing this in? Something's going on a little weird here. Because, yeah, we're not actually getting the terrain attached to these objects. Huh? I've done something. I've broken something. How come these things aren't actually getting their terrain anymore? So I've commented out rebuild chunks. So we're not running this. Oh, right. Derp. DTC is still... we got to call build terrain manually now. Remember we made that change? Build terrain's not being automatically called. So now we call it here. The advantage of calling this here as well as not calling it in this start function, start only gets called before the first update function after the object gets spawned, which means build terrain doesn't normally get called right away. Here we're going to call it right away. So now if I hit play, this will now get our terrain again, which is good. Excellent. And now we can also call the rebuild chunks. But it is very important to note that if we were just trying to call rebuild chunks when build terrain was being called by the start function, build terrain wouldn't have been called yet. So rebuild chunks would fail. But now build terrain is properly being called, which means all the terrain exists, which means now neighbors are being set. And assuming we've done a correct job here, which we clearly have not. And I was going to say things will get stitched together. Is it possible I'm passing the wrong neighbors? That's a possibility. Let's see here. Calling rebuild chunks. We're calling set neighbors. Which are being run here. One thing I would like to do, there's a few things. It'd be very handy if the terrain chunks were named appropriately for wherever they are. So, yeah, a couple of things. When we create the game object, I'm going to call each game object. I think just based on its position. That's going to be fine. That'll give us a little bit more info in the hierarchy, so we can track some things. Okay, there we go. So they've got names now, which is good. And this one is in the bottom left corner. Excellent. So this one's in the top right corner, or top left corner. So I don't think we can ever set neighbors from here. So if we want to check to see which neighbors' terrain chunks are being allocated, I'm just checking to see if these are actually... I think that's what's happening. I think our neighbor code is wrong. Yeah, this ridge is different. I think we're telling... yeah, I don't think we're lining things up properly in our build chunks. Oh, you know what? Yeah, see how this has got a funky edge that wasn't there before? You know what it is? It's... our XY array is not going the way we think. I think the 0, 0's at the bottom. Yeah. So I think this would be bottom. And this would be top. I think that's the problem. Because I was treating Y equals 0 as the top left, or the top row, and it's not. There we go. So now if we look... there we go. Okay, here's an example of there's still a glitch there. There's still a glitch there. Poop. I thought I had it. I'm passing this now, right? Rebuild chunks. Set neighbors. I mean, I put that breakpoint, but that's not doing anything because we're not actually debugging. I'll verify this is getting called actually by linking the debugger in here. And if we hit play, we should get it to There we go. We're getting the blinking over here, which is good. If we hop over this stuff. Null, null, null. We're getting no neighbors whatsoever now. That seems odd. Can I not? There I was going to say, can I not move this up? Oh, no, okay. Null, null, null here. But it's got the right and it's got the top, so those are coming in. Can we name these better? Because it might be a little easier to see. Because we're at the negative number. We're starting at the, we're in the bottom left corner. So we've got a neighbor to our right, and indeed it is the neighbor to our right number. And we've got a neighbor above us. So our X is matched, but it's not there. Okay, so it is actually getting the right chunks passed in as the neighbor. So things are actually working. And yet, they're not. I thought that's what this was supposed to get rid of. It is worth noting I probably have to update the collider as well. I'm actually not sure if the terrain collider... I guess not, because terrain data doesn't have a neighbors. So our terrain collider must not have it either. Get component, terrain collider, set neighbors. Yeah, it doesn't care about that. Which actually might be a little bit funny. How come this isn't working? We're definitely calling it. It's definitely running it. I assumed that set neighbors, this ensures, oh, is it just, oh, it's just to get the level of detail to work correctly with the neighbors. It doesn't actually handle stitching. And actually, the level of detail, it's still got some weird things. Okay, so the stitching here, the seams, are not going to be fixed by this. So for us to fix the seams will require that we actually make sure 100% that these numbers are used in the same place. And right now they're not, and there's a couple of different reasons for it. I think, remember, where's our origin? I guess our origin's in the center, and even it doesn't really line up properly with everything. Could just be some floating point errors. We're going to have to take a look at that. And the other thing I want to check, though, this is not really a proper solution, but if we were to go and dramatically shrink down the degrees per chunk to something more realistic to what we're going to be doing later, to something like that. If we do that, then, well, the world will look pretty flat, but it should also be pretty damn seamless. Which one's our middle piece? This is our middle piece here. How come we're not getting the... There it is. Yeah, it's going to be really flat because we're super duper zoomed in on an area. So it's not really going to be obvious what's going on. And yeah, indeed, we don't have a seam, but that's not terribly fun. If we had a higher resolution image of the moon, this would be a little bit more interesting. About 1 degree for chunks, so it'd take 360 chunks to go from side to side. How does that feel? Yeah, it's got the seam. Okay, well, there is something that definitely needs to be tweaked in my own calculation. Either, again, it's something to do with the math between the math that we use to generate our array right over here. Or it could be something with the conversion from the rotation to the UV. I suspect it might just be inaccuracies that are building up with floating point stuff. But that's probably not the only thing. It's probably not the only thing, though. So we'll, next episode, we will try to deal with that appropriately and eliminate those gaps entirely, because those seams are very unseemly. I know, terrible joke. Just waiting for this to load. So, yeah. And I know that it's these places, these points are not reading from the same one, and that's really something I need to do. And so one of the things that I talked about early on, right, is I talked about passing some sort of grid, something like a array of vector 2s that were the corner UVs, right? And making sure that these are identical between adjoining chunks. because that would guarantee that we were properly going from one to another. Actually, I guess it wouldn't be corner UVs anymore. I don't know. Well, I'll give it some think. There's many ways to do it, but the end result means we have to make sure that our terrain is using, between chunks, the exact same coordinates here. Individually, each terrain is rendering beautifully, and I'm really happy with how they're doing it. In fact, they look a lot better now that we've got our neighbors set up. Like, all the lighting and level of detail is different and looks just better. But they are definitely not lining up right. And again, when we were doing this bigger, we were starting to see a little bit of separation as you went down. You could see the craters sort of split and echoed on the other side because we're clearly not lining things up right. So we'll take another crack at something, which may be entirely this piece of code here, where we calculate the movement between different chunks. Would not surprise me if that were entirely true. But that'll have to wait until next time. Thanks for watching. See you then. Thank you to all our February Patreon supporters, including these Mic Check supporters. We've got Yukofin, Snoopy, TRB, Pavel Zdanov, Drazian, Gavin Power, Jan Torivel, Michael McClintock, Aaron Toyvson, Craig Mortel, the not-so-evil engineer, Julien Auger-Lafont, Maris Fieldvold, Speedysant, Steven Stager, Valiant Cake Fiend, Wes Olenboiving, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil, Blakey, Milner, and absolutely everyone who's watched, shared, favorited, and subscribed. Thank you so much for making this possible.